IUPAC nomenclature for alkanes. So when I was learning this, it was like a lot of information. So I try to condense it as much as possible. So that way it's going to make it much easier for you guys to be able to study and much more efficient. By the way, I'm a pre-med student. I have a 4.0 and I did all these pre-med classes, right? Like I have organic chemistry, I did biochemistry, genetics, biology, general chemistry, obviously. And so if you go to my channel on YouTube, I have all these classes and videos on each subject, which is amazing. I think so that way, I wish I had that resource. So giving that to you guys feels great. And so honestly, please follow me here and on YouTube. That would mean a lot to me. And let's get back into this video. So, oh, one more thing. So on YouTube, it's on playlists, okay? So each class, each subject has it on playlist, and there you go. Okay, so IUPAC nomenclature for alkanes. I know it looks like a lot, but I promise it's not that bad. So what better way to learn nomenclature than actually giving you a name? So the ending tells you what the primary functional group is. And yes, this can change. Like, for example, it doesn't always end in ane. Like sometimes, like for example, alcohols, it'll have like OL at the end. So what I'm trying to say, it depends on the primary functional group. But yes, like you can have, for example, NO, which will be like referring to the alkene, and then ol referring to the alcohol group. But okay, that's a lot for right now. What I'm just trying to say is the ending will tell you the primary functional group. So usually it'll be ane, ene, or ein. Okay. The middle part is going to tell you the number of carbons that you have in the longest chain, okay? And it's the longest chain. Sometimes it's the chain that includes that that group per se. Like if it has an alcohol, it's going to include that alcohol. So again, naming for another time, but it just tells you the number of carbons. Okay, and then here it tells you the substituents. So usually you have a lot of substituents, like if you have 2-methyl or 2,3-dimethyl or whatever, it tells you what the substituents are. But there's some ground rules, okay? So one, just listen to these rules, okay? I promise I have more examples at the end, so that way we can like work out the kinks, but just listen. So first, you need to put it into alphabetical order. It's more important that you put it in alphabetical order. For example, 3-ethyl, 2-methyl, than putting it in numerical order. Notice what I just said. 3-ethyl, 2-methyl. You would think that you were going to put 2-methyl, 3-ethyl. No, that's not going to happen. You're going to put 3-ethyl, 2-methyl. So the numbering doesn't have to be in order. What has to be in order is the alphabet, okay? And again, when you're putting everything in order, you're going to write it down, okay? When I say ignore, I just mean that you're going to go by the next letter. So for example, if you have sec-butyl or tert-butyl, ignore sec and tert, write it down, but you're going to go by butyl, the B. So butyl, like sec-butyl, is going to go before ethyl, is what I'm trying to say. Okay? And then isopropyl is an exception. It counts. The I in iso counts. So again, it would be like 2-ethyl, 4-isopropyl, 5-methyl. Okay, like maybe I should do the numbering in order, but the numbering doesn't have to be in order. What has to be in order, again, is the alphabetical order. And now I want to actually go over the actual, like, applying the application, right? So again, we have my skeletal structure here. I have 1, 2, 3, 4, 5, and I'm showing you that's the longest chain. And yes, technically I could use the blue, but it would still end up on carbon 2. What did I say right now? I could have used this line and then this line. Actually, I'm going to highlight it because you can't see that. I'm going to use this line and then this line, then this line, this line, and have that as my chain. But as you can see, 2 would still be the methyl substituent. So you need to always look for the longest chain and the chain that would give the lowest possible number to the substituents. So I have some examples. Okay, I know I made it all cute and girly and everything, but it's just I feel like you guys have to see it to understand it. So let's go over this. You have to look for the longest possible chain. I sound like a broken record, but it's true. Like, I can't go 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that one's longer. What about 1, 2, 3, 4, 5, 6, 7, 8? No. So you have to go like that, what I just did. And then what you have to do is you have to see what would give the lowest number. So I can't go 1, 2, 3, 4, 5, 6. Oh, my substituent will be on 6. Versus if I go on this side, 1, 2, 3. Oh, my substituents would be on 3. That's what I'm trying to say. So if this is the longest chain, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I have to see, okay, now what? Now I have to see where my substituents are. So I have 2 methyl groups on 3. And yes, you have to write 3,3-dimethyl, because you can have a dimethyl and you can have a methyl on 2 and a methyl on 3, and it would be 2,3-dimethyl, okay? So you have to write that both of them are on carbon 3. And then on 4, you have a Y, which is the isopropyl. I always call it a Y. So, and now you have to put all that information together. So what is going to have priority, the isopropyl or the methyl? And what I mean by that is the I or the M. What comes first in the alphabet? The alphabet. So the I comes before. So it's going to be 4-isopropyl. Then you're going to have 3,3-dimethyl. And how many carbons is nonane? Well, on this, you can't have a space. And then here I have to actually put a dash. And there you go. That's it. That's 4-isopropyl 3,3-dimethyl nonane. Not that bad. Now let's go to the next one. Let's look for the longest chain. Well, could I do 1, 2, 3, 4, 5, 6? No. 1, 2, 3, 4, 5, 6, 7. Yes, but look at the substituent. 1, 2, 3, 4. The substituent would be on 4. Let's do this side. 1, 2, 3. Oh, the substituent would be on 3, 4, 5, 6, 7. Okay, so I'm going to prefer the one that's the substituents go on 3. I know this is similar to the last one, but I wanted you guys to actually see that you can also have a trimethyl. So it's going to be 3, 3, 4 trimethyl, and then heptane. And again, no spaces between the last one. Now, let's do this last one together. Again, look for the longest chain. So 1, 2, 3, 4, 5, 6, 7. I don't know why I put all 7s on here. But it's okay. I guess just if you see what the point is, you'll be able to do that. Okay, 1, 2, 3, 4, 5, 6. No. Okay. 1, 2, 3, 4, 5, 6, 7. Yes. But then where's the substituent? 1, 2, 3, 4. No. 1, 2, 3, 4, 5, 6, 7. Yes. And then now that you see that, you're like, okay, well, my substituents are on 3 and on 4. 3 is the lowest possible, so that's why I'm using this side, okay? Now, I have 2 methyl groups on 3, and I have 2 ethyl groups on 4. So what am I going to put first? An E or an M? And obviously it's going to be an M. And I like the ethyls because they look like little bat wings. Okay, I'm sorry. 4,4-diethyl, and then you have 3,3-dimethyl. And again, you're going to have to put a dash and then a heptane. And there you go. That's the name. If you enjoyed this video, next one, sneak peek, I'm doing cycloalkanes, so stay tuned for that. If you enjoyed this video, again, please follow, and thanks again for watching.